Hey you guys, so we're getting ready to start chapter 5, which will be the last chapter that we'll get to before your semester exams. And I just wanted to show you the calendar. There's actually a copy of this on Canvas, but when I get back on Wednesday, I'll give you a color copy. I just wanted you to see that we're going to get through 4 sections of chapter 5, and then we'll have what I call a mini test, right? One of those half test grades. I believe so far this quarter we've only had one test grade. That's chapter 4. So this will be a half, just so that one test grade is not going to be, the full 70% of your grade. Also notice we'll have an in-class quiz here on Friday, just covering the first 2 sections. So I believe right now that finals schedule is still tentative, but I went ahead and put it down so you can kind of get an idea of what it's going to be. So before we can start chapter 5, we need to do a little kind of prerequisites review, because chapter 5 is all about exponential and log functions. And so you need to remember all of your Algebra 2 and pre-calculus related to these before we can start on the calculus. So let's do a quick look. A couple things we need to remember. First of all, how to convert back and forth from exponential to log or log to exponential. Remember, the idea is you have a base, right? The b is your base. You have your exponent, and then I'm going to call this a for answer. And the way it would turn into a log is, this is read, log base b of the answer equals the exponent. And something you'll hear me say quite a bit is that a log always equals an exponent. A log equals an exponent. So it's a good way to kind of remember how to convert. So if you have 3 squared equals 9, that would convert into log base 3 of 9. And notice the answer to the log is the exponent. Remember, when you have e, when you first convert it, you're going to say log base e equals 2, right? Because the answer is the exponent. But remember how you learned log base e is the same as saying ln. And I always have, whenever I first go over this, I always have students say, okay, but is it all right if we leave it as log base e? And the answer is no. Don't leave it, because this is the correct notation. This is what you'll see in textbooks from now on. This is what you'll see on tests, quizzes, AP exam, whatever. Okay, so just to practice, if I'm going to convert this to log form, I would say log base 5, and remember the base is the subscript of the answer, so of 1 over 25 equals the exponent, which is negative 2. All right, similarly, I could say log base 8 of 1, right, of the answer equals 0. So let's say I'm going to go the other direction, right? I have log base 3 of 1 equals 0. So the base is 3 and the exponent is 0. So 3 to the 0 equals 1. And I'm hoping that you're noticing that these are very similar, right? I wanted to point out one of the little handy-dandy shortcuts that you need to remember forever is anytime you take the log of 1, the answer is always 0, which hopefully makes sense, because if the exponent is 0, the whole thing is going to equal 1. And the same thing is true even if we're talking about natural log, right? If I were to convert it, the base that's right here that you don't see, right? The base that's right there that you don't see is e. So e, the exponent is 0, so e to the 0 equals 1. So again, make sure you guys are recognizing this concept as an important one. The log of 1, no matter what the base, always equals 0. Okay, so let's kind of keep practicing. If I were to convert this to exponential, the base is 9, right? The log always equals the exponent, so the exponent is 1/2, and that should equal 3, which makes sense, right? Because 1/2 is the same as saying square root of 9. On this one, if I were to convert it to exponential, so the base that we don't see that's right here is an e. So e to the exponent is a. So e to the a equals 5. Now this one's going to look a little strange because it looks like you have the e there, but remember the base that you don't see is right here, right? And that base that we don't see is an e. The exponent is the 1. And then it's supposed to equal whatever is right here, right? So it's supposed to equal, which makes sense, right? E to the first is e. If I were to convert this, The base that I don't see right here is an e. The exponent is 2. And that's supposed to equal whatever is right here, which we have as e squared, which is a true statement. Hopefully you'll see that I'm trying to kind of drive home a point. If I were to convert this one, the base that I don't see right here is an e, right? The exponent has to be the x, and it's supposed to equal whatever is right here, which is e to the x. Again, is a true statement. So I'm trying to show you another one of those big things that you should remember forever, right? One of those common things. The natural log of e to any exponent always just equals that exponent. I know a lot of students say, oh, the log and the e cancel out. Well, I can see where you think that. I don't like to use that terminology, but essentially that's kind of what it looks like happens. So I want you, with that in mind, when you go through this next little part where we have to evaluate, remember what I kept telling you before. A log equals an exponent. So when you look at this, the idea is the log has to equal the exponent. So what exponent on 3 would equal 9? Well, it has to be 2, right? Or maybe we come down here and we say, oh look, hey, this is the shortcut, right? The natural log of e to any power just equals that power. So see if you can apply those kind of handy-dandy shortcuts and finish this number 1 through 10. So I suggest you pause the video right there, actually get those filled in. I have answers to these on Canvas, but I really think the best thing you can do is kind of use this video interactively. Pause where I ask you to pause. So here's going to be one of those places. Pause where I ask you to pause, and then go check your answers with what is listed. Okay? So go ahead and pause the video and go check. All right, so the next important thing you need to remember from pre-calculus are the parent functions, right, for both natural log and e. So this right here, natural log, would be your parent function. Remember, the natural log is the one that goes through the x-axis at 0, and it looks, oops, sorry about that. It looks something like this. That's the basic shape. Keep in mind that on this graph, the y-axis is an asymptote, and then this will continue to go up, right? So then you can apply all the different transformations, right? I'm not going to do all of them because I want you to kind of think through them, but let's say, for example, I go over here to number 14, right? So if I think about the basic log graph, which is the one that we just graphed, and notice if there's a +2 at the end, right? The +2 at the end means the whole thing is raised up 2. So the point that was right here is going to be raised up 2. It's going to go through right there. So no longer do I have that one. And if all I did was raise it up, I haven't changed the asymptote. So the y-axis is still the vertical asymptote. And if I were to draw that shape, that same basic shape, there it is. So you try 12 and 13. Again, pause the video, try 12 and 13. Think about the basic transformations on the basic log graph. All right, so then let's go down to the exponential graph, right? The exponential graph is the other parent function. So in this case, it doesn't go through the x-axis, but it goes through the y-axis at 1, and so the basic shape is something like this, and where the natural log had a vertical asymptote, right, the exponential function has a horizontal asymptote right here at 0. So again, apply the same basic transformations to these. Let's say we look at number 17. On number 17, because the -2 is up there with the x, there's kind of an implied parenthesis right there, right? It's not out at the end. So this is not going to move it down 2, but rather it's going to move it to the right 2. So the point that was right here at 1 on the y-axis is if I move it to the right 2, it's going to go through right here. Again, if I just take that basic shape, move it to the right, something like that, so I'm still going to have an asymptote, a horizontal asymptote right there at 0. So again, go ahead and pause the video, try 16 and 18, and just apply the basic transformations to your exponential graph. Okay, next thing we need to kind of refresh on are the basic properties of logarithms that you learned back in Algebra 2 and pre-calculus. So technically this should be at least the third time you've seen this. Remember, we have the rule that if you add two logarithms, you can combine them into one logarithm of the product, right, a times b. Now I'm using natural log for all of my properties, but it doesn't have to be natural log. It could be log base 3, log base 10, log base 7. I tend to use natural log because that's what we're going to use a lot more of in chapter 5 when we do derivatives and stuff like that. So then the second one you probably already have filled in, right? If they're being subtracted, it's the natural log of a over b. And something I want to be sure and point out is that it is not natural log of a over natural log of b, right? That is not the case. You're not combining them into division of two logs, but rather the log of a division problem. Okay, so I really don't even want to leave this. I'm going to put kind of a big giant X through it. So I want you to see that's a common mistake, but don't do it. Okay, and then the last property is if you have the log of some power, something with an exponent, then if you want, you can move that exponent down in front, so that whatever that exponent is can come down in front, and then you just have log of x, right? And so it just kind of depends on the context of the problem. You might want the exponent down in front, or you might want it up here as an exponent. So expand. So expand means let's take this one logarithm and stretch it out using the properties into as many logs as we can. And the first thing I would think about on this one is that if the square root means an exponent of 1/2, then actually you have x times y to the 1/2. So I would use property number 3 first, move that 1/2 down in front. There's the 1/2. And now you have the natural log of xy. We'll now apply the first property, right, where it's the log of a product. So it would be the log of x plus the log of y. Or in this case, same concept. How about the first thing we do is move the 2 down in front, right? So I have 2 and then the log of this fraction. And now think about it. If I think about subtraction, right? So there, I want to put the 2 out in front of the whole thing. So I have the log of the top minus, and instead of saying log of AB, I'm going to go ahead and stretch that out because it's a product and say log of A plus log of B, but make sure you notice it's minus the whole thing because the AB was in the denominator. And if you wanted to distribute that negative, you could. And quite honestly, back in Algebra 2 and pre-calculus, depending on who your teacher was, you may or may not have done that many of these where you take one logarithm and stretch it out because it doesn't make sense. A lot of teachers think, wouldn't you rather have it simplified as one logarithm instead of a whole bunch of logarithms? In fact, the ones that make more sense to those teachers, assuming they haven't taught calculus, is this type. What if you have several logs? Can you condense it down to just one logarithm? Well, let's think about it. I can't combine these yet because if you'll notice up here on number 1, you can't combine them if there's a number in front, right? You can't combine them into a product if you have a number in front. So before I can do anything, I'm going to have to move this 3 up to be an exponent, and I'll move this 1/2 up to be an exponent. So I actually have natural log of x squared plus natural log of y cubed minus natural log, and you can either write a to the 1/2, or if you'd rather, you can even write square root of a. It doesn't really matter. Now that I don't have any numbers in front, I can use properties 1 and 2, and I can say, all right, this is going to be the natural log of x squared times y cubed, and then because of the subtraction, that's going to be over the square root of a. So it's one logarithm of that big mess. And like I said, a lot of pre-calculus and algebra 2 teachers do a lot of these and not so many of these, but truthfully in calculus, we would rather have several logarithms that are all individually basic logarithms then we would have one logarithm that's big and ugly. And you'll see why when we actually get to the calculus part of it. Okay, one last thing we need to kind of do a refresher on, and that is actually solving the exponential and log equations, which this is going to gradually come up throughout chapter 5, maybe not as much in the first section, but it's going to gradually come up as we go through. So in general, if you're solving exponential, notice number 22 and 23 start out as exponential, and the rest of them, 24, 25, 26, 27, all start out as logarithm problems, right? So in general, if you're solving exponential, there's two types. If you can get the same base, great, do it. If you can't, then your only option is going to be to convert to log form. So if I change this into log form, right? And the way I think of it is the way we were doing on that table at the very beginning, right? If I look at this, this is log base e of the answer equals the exponent, right? So log base e, so natural log of the answer equals the exponent. And in this case, I'm done. I've solved for x. Now, I will say this, a lot of teachers don't teach it to change the form, but what they say instead is, hey, take the log of both sides. So if you were to take the log of both sides of this, so I'm going to move this one down just to kind of show you maybe an alternate form that makes more sense to you. If when I solve this one, instead of changing the form, what if I said, hey, I'm going to take the log of both sides. So I'm going to take the log of this side and the log of this side. And so if you think about over here, the natural log and the e cancels, so all I have is x. And on this side, I have natural log of 4. Well, either way you want to look at it, we're going to get the same answer, right? Okay, on this one, I don't have the same setup. I could take the log of both sides, but it's not going to be a nice, easy cancel. So again, what I would do is I would think about this as being the same base. If this is e to the x plus 4, instead of thinking of this as being 1 over e, isn't the inside of the parentheses like an e to the negative 1? Right, 1 over e is the same as e to the negative 1. And if all of that is being squared, isn't just the right side, isn't this the same as e to the negative 2? Okay, so if e to the x plus 4 equals e to the negative 2, look, if you have the same base, right, and they're equal, doesn't that mean that the exponents have to be equal? So in other words, x plus 4 has to equal negative 2. So there's several different ways to kind of look at these, and if I finish solving, subtract my 4, x is going to equal negative 6. So those are two possible ways to solve exponential equations, right? In general, on a log equation, the way to solve it is to change to exponential form, right? So if I change this to exponential form, remember the base that is right here that we don't see is an e. So e to the, remember the answer to the log is the exponent, and that would have to equal x. So in this case, just by converting, I'm done. I have solved for x, right? But they don't all turn out that way. On this one, I can't convert to exponential form until I have one logarithm. So use your properties to combine these two logarithms, right? It's subtraction, so you're going to have natural log of x over x plus 2 equals 10. Okay, now let's change it to exponential form. So e to the 10th equals x over x plus 2. And it's interesting to me because this is where I usually lose students. You know, so far so good, but now how am I going to solve for x? Well, I've got to get this out of the denominator, right? So how about I multiply by x plus 2, so I have e to the 10th times x plus 2 equals x. And so if I have multiple x terms, I'm going to get all my x terms on the same side. I just don't want them to be fractions. So I'm going to need to distribute the e to the 10th. So x times e to the 10th, remember e to the 10th is just a constant, plus 2 times e to the 10th equals x. Well, I have two x terms. This is an x term, and this is an x term. I want those on the same side, so I'm going to move this one over, right, and subtract it. So on the left, I already had the x. Now I'm subtracting x times e to the 10th, and what I have on the left side is just the 2e to the 10th. Well, if I want to solve for x, how about if I factor out an x over here, right? It's a common factor, isn't it? So if I factor out an x, on the right side, I'm going to have x times 1 minus e to the 10th. And then on the left side, I have 2e to the 10th. And if I want to solve for x, wouldn't I just divide by that parenthesis? So x equals 2e to the 10th over 1 minus e to the 10th. And you guys are BC students, so I know you're not even thinking that we can cancel out those e to the 10ths. And there I've solved for x. Okay, I'm going to let you guys try 26 and 27. They're actually a little more straightforward than number 25. I'll just say this. On number 26, you can't change it to exponential form until you combine those using your property. And then on 27, the log is already by itself. So go ahead and change this to exponential form. Okay? So when we get to the end of this page, right, and again, I would say you should pause. Go ahead and try and do the solving and then compare your answers with what I have posted. And I'm going to call this the end of the first video, which is just the prerequisite stuff. This is by no means all of today's lesson. This is just the Algebra 2 and pre-calculus part. So as soon as you try 26, 27, you compare your answers, then you really need to go on to the next video, which is actually starting chapter 5, which will then take us to your actual homework that'll be due on Wednesday.